All right. Hi, my name is Erik. I work at Collabora, and I'm here to talk about Zink, which is an implementation of OpenGL on top of Vulkan. So first, I'm going to look at what Zink is, and to talk about what Zink is, I first need to talk about what Mesa and Gallium is. So Mesa is an open source implementation of several different graphics APIs. And Gallium is a hardware abstraction layer inside of Mesa. It has a state tracker and driver architecture, which means that the state trackers are implementations of the API states, and then that pushes down to the drivers. So the drivers are relatively simple. Mesa has a Gallium state tracker for OpenGL, and that's what we're targeting here. It also has state trackers for other APIs. Some of them are useful for us, like DRI, GLX, and WGL. OpenCL, and yeah, DirectX 9, and various video APIs. Mesa also contains a GLSL compiler, which is of proper high quality. And spits out an SSA intermediate representation called NIR. So Zink is a Gallium driver in Mesa, and it outputs Vulkan commands rather than a command list for or a command buffer for a normal GPU. It includes a NIR to SPIR-V compiler, and when we put all of these things together, we have a fully functional Vulkan to OpenGL translation layer. It's currently in early prototype stage, which I tend to say. We support OpenGL 2.1, currently only tested actively on top of Intel's ANV open source Vulkan driver. But some people have run it on other GPUs. There's some experimental patches around for some higher OpenGL versions and some more GPUs. It's not really kind of ready for prime time use yet. There's still much more work to be done, and it's currently out of tree in Mesa. That means that it lives in a fork. So yeah, why would we want to implement OpenGL on top of Vulkan? So we start with this. This is more or less a joke. There's a lot of implementations out there. They have differences, and that kind of can get tricky. But there's some more reasons than that. So I think there's three major reasons. And one is that Vulkan is the future of open graphics standards. But at the same time, OpenGL is a requirement for desktop. But we can also, in addition to this, enable more use cases. Maybe. So yeah, Vulkan has been around for more than 3 years, which has been enough, I think, to say that it's a success. It's proven itself, and it's moving fast these days. OpenGL is pretty old by now, and it's moving at a much lower speed. It's not dead, but it's not exactly young and vigorous, I would say. So I think it's a pretty safe bet that Vulkan is going to be the leading high-end or high-performance API going forward. But yeah, so an OpenGL is an absolute requirement. It's very widely adopted, very widely used. We can't ignore it. Some applications will never be ported over to Vulkan. Some simply because of lack of resources. Some were already shipped a long time ago. Maybe the developers are out of business. Maybe the source code is no longer available. That kind of problems. Yeah, and some just don't really need the benefit of the increased or decreased CPU overhead. So, yeah. But yeah. We need to keep stuff working somehow, but especially in the open source world, it's much better for the community if we can implement an OpenGL driver once and Everyone just have to develop one Vulkan driver for their new hardware. Yeah, and some of the more use cases here is, so what kind of motivated me to start looking at this was working with GPU virtualization. If you're going to virtualize a desktop currently, you need to implement both virtualization for OpenGL and for Vulkan. And the virtualization code runs at a very high privilege level. Basically runs inside the hypervisor, or often does. It's much nicer or much easier to vet one set of Vulkan virtualization and do fully inside the guest the OpenGL to Vulkan. But besides that, maybe we can also bring the full OpenGL support to platforms that don't currently have full OpenGL. This can allow us to port some applications that currently won't run. And we can also maybe even build hybrid applications that uses both OpenGL and Vulkan, where Zink can maybe receive command buffers, for instance, directly into there. This can be useful for porting, gradually porting big applications. Yeah. So why I based this on Mesa is that's where the XKCD slide actually is a little bit serious. Implementing a complete desktop OpenGL implementation, that's a huge amount of work. Mesa already did the vast majority of it, so we want to benefit from that. Pre-existing solutions only solves part of the problem. Both Glove and Angle only do OpenGL ES. That's enough for getting rid of OpenGL drivers on mobile, but not on desktop. VKGL, which is a similar effort, only does OpenGL 3.2 core profile. So again, it doesn't replace for a lot of legacy programs. So the current state of it is that OpenGL 2.1, most functionality work. There's a few little features that haven't been dealt with correctly yet. For instance, the GL polygon mode can't do separate front and back states. Arbitrary texture border colors are unsupported. Flat shading uses the wrong provoking vertex. The wrong provoking vertex, so it misrenders flat shading. And edge flags, for instance, are completely missing. OpenGL 3, we have some patches for that. For that, we require transform feedback and conditional rendering, which we luckily have some AXT extensions for. Things that we still need to solve there is arbitrary primitive restart indices, but we can probably just rewrite the index buffer. Yeah, so OpenGL 3.1 to 3.3, there's some stuff to be done there. Geometry shaders and UBOs need work. OpenGL 4 to 4.6 has a bunch of challenges, but I can't really see anything that's a huge showstopper. It might need some boring emulation here and there, but so I'm gonna run a couple of demos here. Oh, this is this is Quake 3, I guess. So as you can see, this runs okay. I'm not aware of anything misrendering here. Yeah, it's a bit awkward with the. Oops. Something happened to my mouse cursor. Yeah, okay, I lost my mouse cursor. I was going to show you Blender. I have it here on my screen, but I can't move it over. So I'm going to just continue. Yeah, so yeah, there's some features that needs emulation. First thing is the provoking vertex. So the problem there is that OpenGL supports either first or last vertex as the provoking vertex. That is the vertex it will pick flat shaded colors from. Vulkan only supports the first one. We currently just ignore this and just use the wrong one. This, of course, causes rendering issues with applications that use flat shading. We have some options for emulation here. I have an implementation that does rewrites the index buffer, but it leads to some other problems. So my plan is to switch to a geometry shader that reorders the vertices out of there instead. That might also have some difficulties, but I think those are easier to solve. Yeah, the polygon mode, I don't really have a good fix for. So OpenGL can render front faces and back faces with different draw mode. They can expand to lines for a front face and fill for a back face. Vulkan doesn't have that. We can maybe fake it a little bit and render all the back faces first and all the front faces, something along those lines. It's not going to be great, it's not going to be correct, but maybe it works for some applications. Yeah, I'm not sure. Like, this is a pretty low priority thing for me. Texture border colors. So OpenGL allows you to specify any border color you want for textures, and Vulkan has a list of 3 different colors. I currently just hardcode it to transparent black, which I don't really know of any application that uses it. So I haven't seen this be a problem otherwise in any other places than in synthetic tests. But we can solve it by injecting some shady code. It sounds awful, but it's actually not quite as bad. There's some pretty efficient ways of doing it where you can offload some of it to some of the pre-existing border colors and blend in the result in the end. Yeah, so in the future, there's also some kind of challenges. One thing is that I'm a bit worried about relying on ext extensions for correctness. The problem is that they are probably not going to stick around forever unless they become a core part of Vulkan, and probably not even supported on all of the GPUs. So we're going to have some, I think, more robust solutions in the long term. For transform feedback, I think maybe we can get away with writing stuff to an SSBO. But there's similar issues with other extensions as well. So if you want to get involved in this, the code is in the freedesktop.org GitLab instance. There's some various branches there. There's an issue board and a wiki, but all of this will move to the main Mesa project once we're upstreaming, which I hope is soon. Yeah, and you can contact me via some of the magic of the internet here. yeah, but yeah, and I would like to thank a couple of people who have helped out. Dave Early from Red Hat has done a lot of work, both on features and performance, yeah, and the Windows system integration code. Jason Ekstrand from Intel has helped me a lot with the shader compiler work, and a lot of other people from the Mesa project. And especially thanks to Collabora for sponsoring this work. And yeah, thanks to Khronos for letting me do this talk. So, that's it. Thank you. Yeah, so we have time for some questions if someone has anything. Yeah. Is there a mic? Is there a mic here?
Oh, my question was, do you have plans to submit your implementation to OpenGL conformance?
Not currently. There's some problems with that, especially in terms of how to do that. I would love to discuss this with Khronos, but I would assume like you would have to test for every hardware, every Vulkan driver you're on top of?
Well, we've done things like the RADV driver does not have to be tested on every AMD part. We encourage broad testing, but there are ways to do that. There are also some legal things which we worked out for RADV by having free desktop become, I think that's how it works. Is free desktop the, no, it's the parent. The ISF is something Software Foundation.
SPI or something?
It's SPI,
yeah.
is a Khronos member.
Yeah.
And so you can make submissions under that umbrella.
Yeah.
So there are ways to do it, we should just talk.
Yeah, I mean, Collabora is also a Khronos member, so...
Oh, right, sure. And that's how Intel does it, just...
Yeah. Yeah, so yeah, I could also imagine maybe like you're using Swift shader and submitting a general kind of on top of software rasterizer could make sense.
I'd just like to thank you very much for your work, because it's actually looks like it's saved our bacon a little bit for the software house that I work for. As people are probably aware, the OpenGL API is going away from macOS, and we're currently using Mesa and Zink on macOS to replace that for when it's finally going. We've done a fair amount of work on it and made a whole bunch of modifications, and we're wondering if you guys are interested in us contributing that back to your repository.
Oh, absolutely. Patches are very much welcome. So yeah, I would love to see patches.
Cool.
Hi, I think this project is really cool. What do you think is necessary to us also support like dry in addition to gallium well?
I didn't get that last part. Sorry. Yeah? Could you yeah.
I think you said that DRI support was experimental. What sort of things need to be fleshed out fully?
No, DRI support is not experimental, I think. But it is a requirement. So, for instance, NVIDIA doesn't do DRI drivers, so it won't work on NVIDIA right now, sadly. I mean, that can probably be fixed by some, other integration. It's just that hasn't been done.
Okay, thank you.
You're welcome.
Okay.
While you're walking, I'm going to do my one little prepared joke. Oh, that was corny.
Since we're in freelance, but it's not actually a question for Erik, it's a question for the gentleman doing work on macOS. So I just wanted to understand, are you going to take Zink and run it on top of Molten VK on top of Metal, or? It's fascinating. Let's talk during the party.
Yeah, emulation on top of emulation is, I'm a little bit afraid of that. I think I would implement something like Zink, but outputting Metal instead. If I were to work actively on that. I don't have a Mac even, so I'm not going to touch that, but yeah. I mean, if it works, it works. All right, is that it? I guess so. Well, thank you guys.